Okay, you now have the skeleton ready, so let's look at making it drive the model. Before we do, I want to point out a few small changes I made since the last video. Previously, we parented the hand twist joints to the hand joints. You can see that they are now instead parented to the lower arm joints, just like the other twist joints. This just makes sure they will follow the lower arm and not be controlled with the wrist. You can see the same here on the opposite side. I also did the same with the foot twist joints, making them instead follow the calf joints. So a small change, but it will make a difference later in the rig. Okay, let's get back to skinning. So what we need is for the model to follow the skeleton, so it can deform and be animated and then eventually exported and used in game. Oops, looks like I left some history on the model. I'll just delete that. A quick way to get back into the main pose is to right-click on the skeleton and go to Assume Preferred Angle. This will only reset the rotations though, so remember at this stage to not adjust the translations on any of the joints. Even though we have this full skeleton, we don't want every joint to affect the model. Some of the joints are here to simply help the others deform the correct way. You have to remember that this is a real-time asset, so we have to be economical with what we use. The more joints that affect the model, the bigger the impact is on the engine. Plus, there is no point having a joint skinned when it does nothing to the model. Okay, let's open the hierarchy and take a look. And we can select all the joints quickly by going to Select Hierarchy. Now deselect the root joint. This is used by the engine, but not the model, so this doesn't need to be skinned. I'm also going to remove the cog joint from the selection. We already have another joint in the same place here, the pelvis joint, so that will control the model. Next, remove the upper arm joints from the selection. Again, we don't need these skinned because we added the extra twist joints here, which will control the shoulder area for us. We can now also remove the hand twist joint too. Okay, let's deselect the opposite side, the upper arm and the hand. We can do the same with the legs, so remove the thigh joints and the foot twist joints. There we go. So those are the only joints we want skinned. It's important to add that we can always add or remove joints later in the rigging process if we need to. So what we're doing now isn't set in stone. What I would recommend doing now is storing these joints in a selection set. Go to Create, Set, Quick Selection Set. Let's give it a name, Bind_joints. What we can do now is create the set, or alternatively create a button on the shelf which will select these joints for us. For now, just click OK to create a new set. You can see the set down here. All I need to do now is right-click on it and choose Select Set Members. That will quickly select those joints again. If we open it up, you can see all the joints inside the set here. So when it comes to rigging, you may find that you need to detach and reattach the model a few times as you're testing how it deforms. This could be to add extra features to the rig later or fix bugs, so it can be useful to have the ability to quickly select these joints. It may not be such an issue on something like this, but if you're working on a high-end rig with a lot more joints, it can be a lifesaver. Okay, with the joints selected, let's look at skinning the model. Add the model to the selection. Go to Skin, Bind Skin and open the options. I'll reset this. As you can see, we have lots of options here. First, we want to change bind so it will only bind to the selected joints. We don't want the full hierarchy. We also want to change maximum influences to 4. This dictates how many joints can affect each vertex. And again, the more influences you have, the bigger impact it will have on the game engine. 4 is usually the amount to use, but it depends on the target platform, so it's always best to check. If you have to change this later on, it will involve repainting a lot of skin weights, so it's good to know from the outset. Let's apply this and see what we get. So the first thing we see is that half the skeleton is now colour coded. This is an option in the settings, but it indicates it's now skinned. Don't worry if it's just coloured half the skeleton like here. It has only done this because of our joint selection. If you want the full skeleton to be coloured, you can instead bind the full joint hierarchy and then manually remove the joints you don't need from the model skin cluster. Speaking of which, you can now see the model has a skin cluster node attached. This stores all the skinning information. We can now also move the skeleton and the model follows. Let's change the view. That's better. So what we have are the default weights, which is a starting point. As you can see, the arm doesn't deform in the right way just yet. Let's look at the fingers. They are a good place to test how things are deforming. You see, this finger looks very soft and spongy. Yes, we can fix this by adjusting the weights, but we could also save ourselves some time by experimenting with the other skinning options. Let's reset the pose. An alternative way to reset the pose of a skinned model is to select Go to Bind Pose under the Skin menu. OK, we want to remove the skinning information now so we can reapply it. This time go to Unbind Skin. This is a much simpler window with just a few options. You can choose to delete the history, which removes the skin cluster completely. Keep the history, which will instead detach the skeleton but keep the skin cluster. This is useful if you need to make some minor adjustments to the skeleton but don't want to lose the skin weights. To then reattach it, you need to use the Bind Skin option again, but it will instead use the existing skin cluster rather than creating a new one. Finally, you can bake the history. This will make the model retain its current pose and position, so effectively bake the deformation into the model. Let's apply that. OK, good. The model is free again. So, select the bind joints again using the selection set, and select the model. Now let's look at the other options. Using the default bind method, which is closest distance, you can see we have a drop-off rate slider which we can use to adjust each joint's influence on the model. Let's set that to the maximum value of 10 and see what the difference is. And apply that. So you can see here around the elbow, the drop-off is a lot harsher, so we get a smaller distance where the joint's influence ends and another begins. Let's undo that and reduce the drop-off rate instead. Now you see the drop-off is much larger, so this joint is affecting a wider area. It's affecting the whole arm now. So that's not ideal for this sort of setup. In this instance, you want to try and keep each joint influence smaller, so a drop-off rate of around 5 or higher would work. OK, so that's the first bind method, closest distance. This tells Maya to use the closest joints to influence the vertices and ignore the hierarchy. In some instances, this can cause unwanted influences of the skeleton if not positioned correctly. As we said in the beginning of this workshop, the creature's arms were lower, so with this option we would run the risk of the finger joints affecting the leg, because with the arms lower, the finger joints are then closer to the leg parts of the model. This again is why we raise the arms slightly. Next we have closest hierarchy, which is a better option in these circumstances. This instead uses the skeleton's structure, so keeps influences restricted to a joint's parent and children instead. Let's quickly try that. You see, it doesn't look much different, and that's because we have the arms in a good position, so closest distance works as well. Heatmap is the one I use most often and is the best option if your model has a higher polygon count. It essentially heats up each joint and uses the falloff to check for and influence the surrounding vertices, so you get a tighter influence. It will also ignore any joints that aren't inside the mesh, so in some cases you may have to go in and add them manually. If we select that option, you will see that we now have a new slider, Heatmap Falloff. Like with closest distance and closest in hierarchy, this controls how far the heat map will search for vertices to influence. Now this does take a little longer to calculate. Okay, so if we look at the elbow again, it's not that different to how we had it before. Where Heatmap really does shine though is with areas like the fingers. You see, we are getting a much better deformation here. The finger is more solid, so it means there's less cleanup work to do. Okay, let's unbind this and see what effect the falloff slider has. Let's set it to 0. Select the joints again, and the model, and then apply. As you can see, the elbow has a greater influence over the model now, but it's a nicer, more gradual influence than when we use closest distance with a low drop-off rate. Let's check the finger again. So this is softer, as you would expect, but it's still an improvement over the default option. Let's undo that and set the falloff to 1. This has tightened things up now, so the finger looks much better, probably better than earlier. We would just need to adjust the crease here a little. And the elbow is a lot harsher now, so what we gained in the fingers, we lost in the other joints. The shoulder works quite well too. Still needs work though, but under the arm looks nicer. Let's undo and compare this with closest distance again. So you can see, with a maximum drop-off rate, this is too harsh. In general, Heatmap gives us a nicer result. Finally, we have geodesic voxels. I rarely use this option if I'm honest, so I'm not going to go into too much detail on it here, but it's great if you have a model that isn't built in the usual way. So for example, it may have non-manifold geometry, where you have multiple polygons sharing an edge. This can be caused when extruding, or just bad modelling practice in general. This will usually mean the Heatmap option won't work, so you can try this instead as an alternative. To be honest though, if your model does have issues like this, they should be addressed before exporting to a game engine, as they will likely cause issues further down the line. Okay, let's quickly look at the other options. Normalize weights will basically try and keep the weight values between 0 and 1. You can set this so it happens as you work on the weights, which is the interactive option. The problem is this can cause other areas you've worked on to change as Maya tries to keep everything even, and in some cases it can make bad decisions, so you end up with vertices affected by the wrong joints. You can get around this though, but I'll discuss that shortly. None simply turns this off, but then you run the risk of weight values being higher than 1. In this instance you would need to normalize the weights manually later, but this can change how the influences are distributed. so you may need to go back in and fix some stray weights. Finally, Post will normalise the weights for you once the model deforms. Again, this may involve you going back and fixing some new weighting problem areas. I would recommend, where possible, keeping this set to interactive, so basically what you see is what you get, and there are no surprises later on. Now, you can control how the normalization is distributed with this option. If you leave it set to distance, you will likely get issues with vertices being assigned the wrong weights. You may have seen this when you're smoothing weights and areas of the model seem to pop out. To combat this, simply change this to neighbour, so the weights, when normalized, are kept local. It will save you so many headaches and make painting weights a more stress-free experience. Okay, so those are the main skinning options. So let's now bind our model and look at what other options are available to you to edit the skin weights. So I want Heatmap, and as mentioned, I'm going to change weight distribution to neighbour. I'll also set the falloff so it's around the default value again, so 0.65. We will select the head model this time too, so that also gets bound. OK, apply that. Let it calculate. And that's done. Just do some quick tests to see how it deforms. Ignore the eyes for now. They will be skinned, but they only need to be influenced by the eye joints. OK, looks good. So here we have our skin cluster node. There are a few options we can change in here, like how the weights are normalized. We will leave that though. The envelope is a good attribute to be aware of. Let's say I have a character posed, but I need to see the model back in its default pose. Maybe I'm working on some blend shapes, for example. I can simply set envelope to 0. This essentially turns off the skin cluster's influence. OK, so, as good as Heatmap is, there may be some joints that got ignored, like this twist joint. It doesn't seem to be attached to a skin cluster, so we need to add those to the main skin cluster too, so they influence the model, and so we can adjust their weights. Let's check the other twist joints. OK, this isn't connected. Ah, that one is. This one is. And so is this one. Probably because the model is thicker in these areas. This one isn't. Or this. Or this one. So let's add that to the selection. With those selected, we just add the model to the selection and go to Skin, Edit Influences, Add Influence, and open the options. I'll reset this. So this will essentially add these joints to the current skin cluster. If I apply this now and move one of the new joints, you see it's influencing the model, but it's overwritten the weight values that were there before. So if you'd spent an hour working on the weights, those would be lost. Not only that, but it means you now have a lot more work to do to clean this up. OK, let's undo that. What I prefer to do when adding influences is to use the Lock Weights option and set the default weight to 0. This will add the joints to the skin cluster but not affect any weighting values that currently exist. You see, the joint doesn't affect the model yet, but it is now attached to the skin cluster node. And we have also maintained the weights we had previously. OK, so now all the joints are connected, let's look at how you can adjust the weighting values. Let's select some vertices around the arm and go to Windows, General Editors, and open the Component Editor. If we look under the Smooth Skins tab, we see a chart. This lists all the vertices down the side and each one's influences across the top. So you can see exactly which joints are affecting which vertex and by how much. What we can also do is change these values to update the weights manually. If we set this column to 0.2, you see the weights change, but all the weight values have also updated to take into account this change. That's the weights being normalized. So that's one way to adjust the weighting, and it's perfect for when you get those stray weights that just don't want to be painted. The main way to adjust the weighting is to interactively paint them, which is much easier and a lot quicker. To open the Paint Weights tool, just go to the rigging shelf and click on this button here. So here we have a list of all the joints that are affecting this model. If you select one, you'll see a grayscale area appear. This is that joint's area of influence. If we scroll down, we will see those twist joints we added manually. You will also see the padlock next to them is yellow, indicating these are locked, which is fine. If you remember, we locked the weights when we added these to stop them influencing the rest of the model's weights. So we just need to go through and unlock these now. Just click on the icon to do this, and let's find the rest while we are here. At the moment, the joints are sorted according to the hierarchy, but you can change this up here. So we can see them alphabetically, hierarchy, or just flat. What we can also do is filter the list. So let's say we just wanted to work on the twist joints. We can input twist here and it will just show us the joints with twist in the name. Down here we can choose what mode we want to work in. Paint, select, or paint select. I rarely use anything but paint here. Next we have the main area where the paint tools are. First is the paint operation area, so you can dictate how you want the strokes to affect the weights. Replace will simply swap the current weight value with the one you have specified. Add will gradually build up an area, so you can continually add a value to it. Scale will simply scale the values, but again I never really use this. Finally, Smooth will gently blend the weights for you to soften and smooth an area out. Next you have your brush types, which range from soft to hard. Normalize weights, we discussed this before, but there are very similar options here. Next we have the opacity and value sliders, which work hand in hand with each other. Opacity is basically a percentage of the value slider. So value is the main weight value, and opacity will paint either all or part of that. If value is set to 0.5, opacity will never be able to paint above that value. This works well as it allows you to gradually adjust the weights. It gives you more control. Let me show you. A quick tip is you can also select which joint to work on in the main view. Just right click on the joint and go to Select Influence. So with opacity and value both set to 1, we get solid white. So these vertices are being influenced by the pelvis joint 100%. If I reduce the opacity, you see we can instead gradually add those weight values. If I instead set opacity to 1 and then drop value, no matter how much we paint, we won't be able to go over the value amount. We can still drop the opacity and gradually add the weights, but they won't go over this value of 0.1456. So those are the main painting tools, and we will see them in action in the next video. Oh yes, one other option is flood. This will simply fill the whole model with that value. So now the model is influenced fully by the pelvis joint. Down here we can control how the influence is represented. Personally, I prefer to work with just grayscale, but you can enable colour feedback if that works best for you. With this enabled, red is the higher weight value. Here we have options to adjust the paint stroke. You can also use a graphics tablet to control the opacity if you want a more interactive painting experience. Also, you have various display options here. So if we didn't want to see the joints through the model, we could disable this. I think that's the main options covered, the ones I use anyway. Obviously there's so much more to this tool, but for this project, those options are fine. Before we end, I also want to show you that you don't always have to paint the weights on the whole model. Let's select these vertices here. Now if I go back to the Paint Weights tool, with opacity and value set to 1, if I paint now, the area I am affecting is restricted to just those vertices. You see, I can paint up here, but nothing happens. I can also use Flood, and it will just update the selection. This can be really useful for blocking in weights quickly, or when you are focusing on just one area. Okay, I think we're at a good point now to end this video. So now you know how to apply and edit skin weights, in the next video let's jump in and start working on our character.